Hey guys, so today we're gonna be starting our second unit on quadratic functions, which are similar to absolute value functions in a few ways, but the main difference is that they're gonna be in a U shape instead of a V shape. So we're gonna start by just graphing the parent function we're talking about because it is a little bit different. When we do a parent function, I'm not worried about any transformations, so I'm going to use traditional numbers. Which are starting with 0 in the middle. Then we would have -1, -2, +1, +2. So if we imagine plugging in -2 where the x is, it would be -2 times itself. So -2 times -2 is +4. -1 times -1 is +1. 0 times 0 is 0, 1 times 1 is 1, and 2 times 2 is 4. So you should notice a pattern here with quadratics and absolute value functions in that it is going to be the same. It's like symmetrical. Oh no, sorry, I didn't mean to do that. It's symmetrical on both sides of the vertex. So with our parent function, this point right here at 0, 0 is our vertex. And then I'm just going to plot my other points. And you might notice that it looks more similar to a U shape. So we're going to try, this might not work very well. Oh no. Sorry. I might edit that part of the video out, but I might not feel like it, so just bear with me, you guys. This thing is being weird. All right, that's as good as I'm gonna make that for right now. You can probably do better on your piece of paper. So there's our parent function, which is y equals x squared, or f of x equals x squared. They mean the same thing. So just like with absolute values, we're going to look at how we could transform this function, which is by adding different layers to it. So everything that I'm going to show you should look really similar to what we did with the absolute value. The only difference is this time we have parentheses and the exponent 2 instead of the brackets that we used for absolute value. But all of these other elements are the same. This negative that's outside of the grouping symbols means a reflection over the x-axis. And we already looked at that with absolute value. You might have a number in front of the parentheses, which would be either a vertical compression or a stretch, depending on what that number is. Remember that, I just want to see the way that Mr. Overall wrote it really quickly. You might remember from absolute value functions that if that number is a fraction smaller than 1, that it would be a compression, and if it's a number bigger than 1, it's a stretch. If there's a negative right here, that would be reflect over y. This number right here that's being added or subtracted inside the grouping symbol is a horizontal shift. And this number here outside of the grouping symbol is a vertical shift. And all of the rules are going to be the same. So if this doesn't make sense to you, that's okay. We are going to look at a bunch of examples. When we Look at this though, the vertex is these two numbers. So again, we'll look at some examples. The vertex of this would be h, comma, k. All right, I'm just going to go back to this for a second and add the domain and range for the parent function. The domain is all real numbers, and the range is y is greater than or equal to 0. Sorry, I don't feel like that should be an equal sign. All right. Okay, let's take a look at the next page and do some examples so that this can start to make more sense. All right, so here we have a couple different transformations. Let's look at them one at a time. First, I have a negative sign right here. So think to yourself what that does. That negative sign means it's going to reflect over the x-axis. And then we have a number in front right here, that number 2. And that is going to represent a vertical stretch by a factor of 2. And the last transformation that we have is here, this plus 2. And remember from our other unit, this means 2 units to the right, or sorry, to the left. Now, there's two parts of this question. The other part was asking us to identify the vertex. Now, if we go back up for just 1 second, remember we said the vertex was h, comma, k. Well, in this one, we don't have a value of k. There's nothing being added outside the grouping symbols. So I could either imagine it, or if it helps you, you could actually write it out if you want. This would really be like adding 0. So here's the tricky part that we're going to have to remember. So just like when it's inside the grouping symbols, it shifts the opposite way that you think. The vertex is also at the opposite coordinates. So if it shifted 2 units left, that means the vertex moved to -2. Okay, and we're going to do more practice with that. So if it's still confusing, that's okay. But our vertex would be at -2, 0. Okay, I'm going to go a little bit more quickly on these last few. So this one, we would have this 1/4, a vertical compression by a factor of 1/4. That's my first transformation. My second transformation would be 3 units to the right. And my third transformation would be 6 units up. So none of that should really feel that new. The new part is now we're looking at the vertex. Uh-oh. All right. Oh, I have to pause. Okay, now we're looking at the vertex, which is going to be, so remember it moved 3 units to the right, so my vertex is actually at +3, 6. Okay, we're going to do 2 more examples like this. This one also has 3 transformations, vertical stretch, by a factor of 3. We have a horizontal translation, 2 units to the right. And we have a vertical translation, which is 5 units down. And that means our vertex is going to be at the coordinates 2, -5. Okay, because we moved 2 units to the right and 5 units down. All right, here is the trickiest one, and the reason is because this one we have a reflection over the y-axis, and that kind of throws the other part off a little bit. So our first transformation here is a reflection across the y-axis. Now this is where it gets tricky because we're reflecting across y. We're moving 4 to the left, but then we're flipping over across y. So it's actually 4 units to the right. And the reason for that is because of the reflection across the y-axis. I may need to pause the video now and upload another one because my computer just froze. All right, I'll continue this in part 2. It's a cliffhanger, right?